This is a question from October-November 2016, question 1. Particles behave differently when in different physical states. So we have three physical states which are solid, liquid, and gases. It says that solid has a fixed volume and a definite shape, whereas gases has no fixed volume and it takes the shape of the container. The question is asking you to define the volume and the shape for liquids. So I am sure by now you have already learned the state of solid, liquid, and gases. We know that liquid takes the shape of the container and it has a fixed volume. Question B. Complete the table to show the separation, arrangement, and movement of particles in each physical state. So as for solid, the separation is it touches one another as it is closely packed, and the movement is that it vibrates. And as for gas, they are not touching with each other because they are randomly arranged and they move randomly as well. Moving on to question C. Name the following changes of state when ice turn into water. Now ice is a solid and it's turning into liquid. So this would be melting. Question 2. Solid carbon dioxide turn directly into gaseous carbon dioxide at room temperature. Now when a solid turns directly into gas, we call that sublimation. This is a question from October-November 2016, question 1a. Dust particles in the air move around in a random way. What term describes the random movement of these dust particles? Now, if you refer to your textbook or the notes that I have uploaded, you will come across a term called Brownian motion. Now, Brownian motion is when the particles in liquid or gases move randomly. So the term that they're looking for in this question is Brownian motion. Question 2. Identify the particles in the air which cause the random movement of the dust particles. Now generally there are dust particles in the air, however they tend to move due to the collision that they have with other molecules or gases that are present in the air. So the particles that are causing these dust particles to move would be the molecules. Molecules of gases such as nitrogen or oxygen that collides with each other and causes the dust particles to move. Question 3. Explain why the dust particles move in this way. Now, nitrogen particles which are present in the air will collide with each other and this will hit the dust. And this is what causes them to move apart and start to move randomly. Question B. When chlorine gas is put into a gas jar, it spreads out to fill the gas jar. When bromine gas is put into a gas jar, it also spreads out to fill out the gas jar. The process takes longer for bromine gas when compared to chlorine gas. Now the question is asking you to describe the way that this gas particle spreads out. Previously, this question was asking you to describe the random movement of the gas particles. However, this question is a little bit different because they're asking you the way it spreads out. So when the dust particles or any sort of molecule moves in the gas from one place to another, we call that process as diffusion. Question 2. Use data from the periodic table to explain why bromine gas takes longer to fill a gas jar than chlorine gas. Now if you look at the periodic table for group 17, you will realize that bromine gas is placed below chlorine gas. This means that bromine gas has a relative atomic mass which is bigger compared to chlorine gas. So you could say that bromine gas is placed below chlorine gas, therefore it has a higher mass compared to chlorine. This will cause the movement of bromine gas to be slower. That is the reason why it takes longer for bromine gas to diffuse. Question 3. Explain why increasing the temperature increases the rate of reaction at which the gas particles spread out. Now this question is actually something that you will learn in your chapter which is later on. However, I'll just give a brief explanation. When the temperature is being increased, what happens is that the particles inside of the gases would gain more kinetic energy. Therefore, this would make them to move faster, and when they move faster, it means that they would spread out at a higher rate. This is a question from February and March 2017, question D. The apparatus shown was set up. After 5 minutes, a red solid appeared along the line marked S. This one. They're asking you why a red solid appeared along this line marked X. So we have got silver nitrate on our left and we have got ammonium dichromate on our right. So they would react with each other to form this. However, the question right now is asking why is it formed this side? Technically, when you have two reactants reacting with each other, you're supposed to form a product which is in middle. But as you can see here, your nitrate has actually traveled further compared to your dichromate, which has only traveled this much. And this is where your product was formed. This technically shows us that this is heavier. That's why it traveled slower and a shorter distance. And this has traveled further, which means that it has a lighter molecule. So you could say that the dichromate ions are heavier than silver ions. So the dichromate ions diffuses slowly over here and travels a shorter distance compared to silver nitrate. This is why the mark is formed closer to the right side and not in the middle instead. I hope this is clear. Question 2. The experiment was repeated at a higher temperature. What effect, if any, would this have on the time taken for the red solid to appear? Now, similarly with the previous question, when temperature is increased, the particles gain a higher kinetic energy which causes them to move faster. So if they move faster, the time taken for the solid to appear would be faster, which is lesser than 5 minutes because the ions are moving at a higher rate. However, please take note that the position of this S will not change. It's just that the mark that is formed would appear to be faster. Now question E is discussing about thermal decomposition. It will be something that to be discussed in your later chapters. Moving on. This is a question from Specimen Paper 2020, question 3. Kinetic theory explains the properties of matter in the terms of the arrangement and movement of particles. Question A. Nitrogen is a gas at room temperature. Nitrogen molecules are spread far apart and move in a random manner at high speed. Question I is asking you to draw the electronic structure of a nitrogen molecule. Now, a molecule is something that comes in a pair like this, so we know that our electronic structure is going to look something like this. Before we draw out our nitrogen, let's look at the electrode configuration of nitrogen. Nitrogen is placed in group 5 and it has 7 electrons present in its atom. Therefore, the electronic configuration of nitrogen would be 2.5. This means there are 2 electrons present on the first shell and 5 electrons present on the second shell. Since the question is only requesting you to draw the outer electron shells, this is the one that you have to take note, which is 5 electrons. So our nitrogen molecule will look like this, and we're gonna have 5 electrons on each outer shell. This would be for the first, and this is the other molecule with 5 electrons. So as you can see here, what happens is that there are 5 electrons initially present in the molecule. However, it receives another 3 from its partner, making it a complete 8 electrons on each shell. So this is how your nitrogen molecule will look like. Question 2. Compare the movement and arrangement of the molecules in solid nitrogen to those in nitrogen gas. So this one is almost similar with the first question that we did. All you have to do is explain the state of matter for solid versus gas. The movement of solid is fixed and it vibrates as the arrangement is closely packed, whereas the movement for gas is random as the arrangement is spread out. Question B. A sealed container contains nitrogen gas. The pressure of the gas is due to the molecules of the gas hitting the walls of the container. Now, using the kinetic theory to explain why the pressure inside the container increases when your temperature is increased. So this is the third time we're saying this question. When temperature is increased, the particles will gain kinetic energy. And when they gain kinetic energy, they would start to move faster. Particles gain energy when heated, therefore the molecules move faster and collides more often. If they collide more often, this means that your pressure is also increased. This is a question from the Specimen Paper 2020, question 1. The following table gives information about 6 substances In this table, you would see the melting and boiling point of each substances as well as the electrical conductivity in solid and liquid state. Now, question A is asking you to tell which substance could possibly be a metal. For metals, we know that they have high melting point and high boiling point. They're also a good electrical conductor in both solid and liquid state. So as you can see here, substance A has high melting point, high boiling point, a good conductor in solid and liquid, so your answer should be A. Question B, state all the substances that are liquid at room temperature. Now, room temperature is typically between 25 degrees Celsius to 30 degrees Celsius. So we need to look for a substance which melting point is below 25 degrees Celsius. It means that this substance should have already melted in a temperature which is below 25 degrees Celsius. If you're not sure how to refer to this table using this information given, what you could do is you could see over here that the melting point means solid has converted into liquid and boiling point means liquid has converted into solid. This means that anything below this temperature is a solid, anything in between this temperature is a liquid, and anything above this temperature is a gas. Now 25 degrees Celsius for substance A falls below this temperature, 25 degrees Celsius falls here. So as you can see here, I have written down at which state will the room temperature be, and you can see that in the column of liquid you would find substance D and substance F. Moving on, question C, which substance could have a macromolecular structure similar to the one of silicon oxide? Now, a macromolecular structure has a very high melting point and boiling point. However, they do not conduct electricity in solid or liquid state. So let's look at our table and find for that information. You can see that substance E has relatively very high temperature. However, they are a poor conductor in solid and liquid state. Therefore, your answer for this part C could be E. Question D, which substance could be propane? Now, propane is a gas at room temperature. As you can see here, it's a 3-carbon alkane and it is a very simple alkane structure. Therefore, it does not require a high melting point or boiling point. Since it is a gas at room temperature, we know that anything which is gas at room temperature would be placed over here. So the substance could be B. Question E, which substance could be sodium chloride? Now, sodium chloride is an ionic compound. An ionic compound has high melting point and boiling point. However, they only conduct electricity when they are in molten or in aqueous state. If you refer back to the table to find high temperature for substances, you would see that A, C, and E have relatively very high temperature. However, only substance C has a poor conductor in solid and a good conductor in liquid. In another word, liquid also means molten or aqueous state. So your answer for this question would be substance C. This is a question from October-November 2016, question 1. The table gives some information about 5 substances. This table shows the melting and boiling point of each substances. They also show you the solubility in water and the electrical conductivity when it is in molten and solid state. Now, molten means it is heated up and melted, and there will be no hydrogen ion or hydroxide ion present. Question A, which substance in the table has ionic bonding? Now, ionic bonding can be found from ionic compound which has a high melting point and high boiling point. However, it only conducts electricity in molten or aqueous state. Now, if we compare all these 5 substances, we can see that G, H, and J has relatively high melting and boiling point. However, it says that only H conducts in molten and does not conduct in solid. So this would be our answer. Question B, which substance in the table has a giant covalent structure? Again, covalent structure has a very high melting and boiling point. However, it does not conduct electricity in molten or solid state. So now that we have ruled out H, The only substance with a high melting point and boiling point could possibly be G or J. And only substance G does not conduct electricity in both molten and solid state. So your answer would be substance G. Now question C is asking you to name a method you could use to separate a mixture of substance J and water. Now let's look at substance J. Substance J has a very high melting and boiling point. It is insoluble in water, however, it conducts electricity in molten. So substance J could be a metal, and we would like to separate metal from water. Therefore, this is pretty simple. All you have to do is filter out the metal from your water. The method we will be using here is called filtration. Question D, name a method you could use to obtain substance F from a mixture of substance F and water. Now let's look at what substance F could possibly be. Substance F has relatively low melting point and boiling point. It is soluble in water. If it is soluble in water, and we will also be separating it from a mixture of that substance itself from water, that means this would require us to do fractional distillation. Remember, when you have a few mixtures combined together, you will require fractional distillation as it is more complex to separate them. Question E, describe how you could obtain a solid sample of substance H from a mixture of substance H and substance G. Now substance H is an ionic compound as we discussed previously. And looking back at substance G, we could see that it has a very high melting point and boiling point. However, it is insoluble in water and does not conduct electricity in both molten or solid state. So substance G could possibly be a macromolecular structure. This means we are trying to obtain an ionic compound from a mixture of the ionic compound and the macromolecular structure. So what we could do is that we could add up the mixtures into water, both substance H and G. And then what we could do is we could filter the mixture. Once you have filtered the mixture, you can heat up the filtrate. Once you have heated up the filtrate, you would be able to remove the water out of the filtrate, and that is how you can get a pure solid sample. Now substance J is a metal. Describe how substance J is able to conduct electricity when it is a solid. Now typically you cannot conduct an electricity when it is in a solid state because there are no free moving ions. So what you have to do is melt them. So you could simply say that melt the solid to obtain molten substance. Now the metal will be able to conduct electricity as there are free moving ions. Now this is a question from the specimen paper 2023, question 1. It says that element X can undergo the following physical changes. Before we answer the question, let's label all this. So question 1I is asking you to name each of the numbered physical changes as shown in figure 1.1. I think this question is pretty simple. I'd just like to add up something. When gases and liquid convert to each other directly, we call that as sublimation. Question 2. One difference between boiling and evaporation is the rate at which the processes occur. Boiling happens at a very fast rate and evaporation takes a much slower time to take place. State one other difference between boiling and evaporation. Now boiling only happens at a specific temperature. For example, water, when you boil it, it converts from liquid to gas only at 100 degrees Celsius. However, if you evaporate liquid into gas for water, it could happen at any given temperature. Question B. Describe the separation, arrangement, and motion of the particles of element X in solid state. Again, this question just wants you to describe the behavior of solid particles. The separation is that they are close to each other, so they touch each other. The arrangement is fixed or regular. And the motion is that it vibrates at its own place. Now question C. Element X is a group 3 metal. It burns in the air to form an oxide X2O3. They're asking to write a symbol equation for this reaction. It means that when X reacts with air, which is oxygen, it will produce X2O3. Now all you have to do from here is to balance it. After balancing the equation, you would get a complete 2 marks. Now oxygen is written as O2 as this is a molecule. This is a question from May, June 2018, question 1. Give the name of the process that is used. to obtain water from aqueous sodium chloride. Now, aqueous sodium chloride is also a liquid and water is also a liquid. When you need to separate one liquid from another liquid, the process that we use is simple distillation. Question B, to produce lead from molten lead bromide. Molten means melted, and in order to separate this ionic compound, we need to use electrolysis. Question C is to separate an insoluble salt from a liquid. Now this is pretty simple. All you have got to do is to filter out your solid from the liquid. The process is known to be as filtration. Question D, to separate the components of petroleum. Now petroleum is a very complex substance which contains a lot of components inside of it. Therefore, you need to use something which is more complicated, which is called fractional distillation. Fractional distillation is when you separate the components according to their boiling points. Question E, to separate a mixture of colored dyes. I'm sure you have heard of chromatography before, and the function of chromatography is to separate the mixture or component inside a colored dye. This is a question from February-March 2019, and this question is about extraction from an ore. This is technically chapter 10. However, I would just like to discuss the first part of this question, as they're asking you to name the process in which liquid titanium chloride could be separated from the liquid impurities. Again, when there is a few different components or liquid mixed up together and you're trying to extract it, we would use something more complex called fractional distillation. Fractional distillation is when you use different boiling points to separate the components in a liquid. This is a question from February-March 2017. Question 1. State the name of the process that is used to separate oxygen from liquid air. Now, there are a lot of components that you can find in air, and in order to separate only one component, you need to use fractional distillation as discussed before. Question 2. Separate the individual dyes in ink. To separate dye, you need to use chromatography. Question 3. Produce alcohol from simple sugars. This is fermentation. Question 4. Obtain water from aqueous sodium chloride. In order to separate water from another aqueous solution, you just need to do simple distillation. Question 5. Separate the precipitate formed when aqueous silver nitrate is added to aqueous sodium chloride. This means that you're trying to separate solid from a liquid, so this is simple. You just need to use filtration. If you refer to the notes that I have uploaded, you can see there are a certain methods of purification over here. You could read it through to understand better for how to answer these types of questions. This is a question from October-November 2016 about polymer. However, question A and B would be something that we discuss later on. And question C is about chromatography, so we will discuss that now. A colorless mixture of amino acids were separated by chromatography. Amino acid X has an RF value of 0.8. Now, if you refer to the notes that I have uploaded, you would see that in order to calculate the RF value, you would find the distance traveled by the solute and divide it with the distance traveled by the solvent. So if you write the formula correctly, you would be able to get 1 mark. They're asking you to put a ring on the diagram around the spot caused by amino acid X. Now, amino acid X has an RF value of 0.8. As you can see on this chromatography paper here, we have 3 different components that has been separated, and we want to know that which one of these is amino acid. So we can determine that by estimating which one would give us an RF value of 0.8. Let's take the first component and just estimate what could be the RF value. Let's assume that X is the distance traveled by solute and Y would be the distance traveled by solvent. Now this means that X over Y would give us a value of 0.8. Assuming that Y is 1, if this is the distance of Y which is equal to 1, technically your X should be 0.8. And if you look at this picture, this could possibly be somewhere about 0.2. This could be a distance of 0.6. And now this furthest component could possibly travel a distance of 0.8. So it's only possible for us to put a round ring on this side to show that this could possibly be amino acid.